The ICARUS project is an aeronautics and astronautics design project at the University of Southampton. The students are hoping to achieve the world's best wingsuit in terms of glide ratio. I'm the student's lecturer, but I'm also the pilot for the project, so I'm using everything I've learned over a career in skydiving, wingsuiting and base jumping to enable the students to move their ideas to reality. The ultimate aim of the project is to set some world records. The records we're hoping to achieve are the highest altitude wingsuit jump, the longest flight time, the highest speed ever achieved in a wingsuit, and also the longest distance travelled.
For the building of the wingsuit, we began from complete scratch. We sort of were aware of existing designs, but we sort of took that and started from a really basic design, just sort of an aerofoil shape, similar to what you'd have on an airplane, and started working from there to make it sort of molding into the shape of a wingsuit. Moreover, we worked with Angelo's body. We got a 3D scan of his body and made sure that everything fit around him perfectly. For some of our manufacturing, we utilize a lot of the university workshops we have. So for example, the vortex generators, which are essentially little triangular strips on his back. They were manufactured in-house. The wingsuit is being manufactured by a company in France that we've partnered up with. We will send them the designs and they will be helping us make it a reality. One of the other elements that's been produced with help from a specialist manufacturer has been the helmet, the ball-joint helmet. We've partnered up with a manufacturer of longboard helmets, and they've been able to really help produce that sort of aerodynamic design that we're looking for.
So after doing the computational testing, it's really important for us to then test in the wind tunnel and get some physical results, because it allows us to see the difference between our computational results and also these results. And also, sometimes you think things are going to react in a certain way after doing it computationally, and then you see it for real and it acts a bit different. So we strap Angelo into a rig that I designed last year for my dissertation project. We then run the tunnel at about 30 metres per second, which is about 70 miles per hour. And then from the control room, we gather data and see the aerodynamic performance between lift and drag, and also the ratio between the two. In real life, in the real flight, he'll be experiencing speeds up to 3 times faster than we're testing.
Angelo is going to be test jumping in Salisbury, and it's going to be at 15,000 feet and 20,000 feet, which is around the maximum height you can go without oxygen. We're going to be testing a variety of accessories ranging from winglets to helmet and fins and so on. So testing experimental wingsuit with lots of different accessories which we've put on there is really exciting. We've done really extensive CFD and a lot of modelling and a lot of computational work. So definitely I think we should be able to predict how aerodynamically it's going to act.
The next stage after the initial test jumps are to progress to higher and higher altitudes. So starting at 15,000 feet, we'll progress to 22,000 feet, 30,000 feet, and then eventually the record attempt at 45,000 feet. Now, as you go up in altitude, you have to use different equipment. It also gets a lot colder as you go higher. So we'll be looking at things like using pure oxygen gear, halo gear, and then thermal insulation. We'll be doing some climatic wind tunnel tests where we expose my body and the wingsuit and the equipment to very low temperatures in the region of -55. With wind chill, you're down at about -110 degrees, so it's pretty hard on the human body, obviously. We need to make sure that I'm in tip-top shape, so I'm training regularly, cardiovascular fitness and strength training to make sure that I can deal with that kind of conditions.